It's me again, just continuing on. Now I wanted to talk more about this Sp3 hybridization, which is going to have an electron geometry domain of tetrahedral. There are different shapes that we can get where the total number of bonds or lone pair electrons is always going to add up to 4. So just for some terminology, when I'm drawing over here, A is the central atom and X would be any other atom. So the classic tetrahedral shape is going to be one atom in the middle, and then as your central atom, and then 4 going around. So an example of this would be carbon a lot of times is in the middle because it can bond 4 times, and then your X going around really could be anything. And then if I go over here, the number of bonds, there's 1, 2, 3, 4. There's no number of non-bonds. There's no lone pair electrons. We'll get to some of those in just a minute. And then there's something called ABE. And ABE is just a shorthand way of kind of describing. A is the central atom, B is the number of bonds, so there's 4 bonds around that carbon, and then there is no E because there are no lone pairs. You could think of it being an E sub-0 if you wanted. For now, we're going to leave this column blank. I'll explain that more in the next lesson. So the next one is still considered to be an electron geometry of tetrahedral because we still have 4 total areas of bonding and lone pairs. But this is the example where it's a trig pyramidal. Triangular pyramidal shapes are going to have 3 bonds, and then there's this lone pair of electrons on the top. You don't really draw them like that, but I like to just show you those. But over here is how we would really draw it. So it would be, an example would be like nitrogen in the middle, has that lone pair on top, and then 3 things going around. It's still a total of 4, so it's still considered a tetrahedral geometry, but the shape is trig pyramidal. 3 bonds, 1 lone pair of electrons, so then that translates to AB3 because there's 3 bonds, E1 because there's 1 lone pair. So I want to show you that with the PHET soon. So another type of tetrahedral geometry is bent. Again, you've got a total of 4 areas. This time you have 2 bonds and 2 lone pair electrons. Water is an example here. So oxygen in the central has 2 bonds and 2 lone pairs. So then that translates to AB2E2. And then lastly, we have a tetrahedral geometry that's linear, where your central atom, you can really just choose which one you want to be the central now. So if we assume that chlorine is the central, it has 1 bond, and then it has the 3 lone pairs around it. So that translates to ABE3.